everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. So in this session, I am going to discuss about problems on normal distribution. So first problem, for a normally distributed variate with mean 1 and standard deviation is 3, find P of probability of 3.43 less than or equal to x less than or equal to 6.19. Second one, P of minus 1.43 less than or equal to x less than or equal to 6.19. Okay, so for a normally distributed variate with mean 1 and standard deviation is 3. So mean is nothing but, so in normal distribution mean is denoted with the mu and standard deviation is denoted with sigma. Okay, so from this we have, so mean mu equal to 1 and standard deviation sigma equal to 3. So according to our first question is P of 3.43 less than or equal to x less than or equal to 6.19. So this can be written as P of x1 less than or equal to x less than or equal to x2. So which will be in the form of P of x1 less than or equal to x less than or equal to x2. So here x1 equal to 3.43 and x2 equal to 6.19. So according to normal distribution formula, z equal to, we have a formula that is z equal to x minus mu by sigma. So according to that formula, we need to find, here we have x1 and x2, both values are there. So that's why we need to find z1 and z2. z1 equal to, we know that x1 minus mu by sigma. So what is x1? We know that x1 equal to 3.43 minus mu value is 1. Mu value is 1 and divided by sigma. Sigma value is 3. Okay, so substitute all these values in the formula. We will get, after simplification, we will get z1 equal to 0.81. So like that, we need to find z2 value. So z2 equal to x2 minus mu by sigma. So x2 value is 6.19 minus 1. Mu value is 1 and sigma value is 3. So after simplification, we will get z2 equal to 1.73. So now P of z1 equal to P of probability of z1 less than or equal to z less than or equal to z2, that is equal to, so z1 value is 0. Already we have solved. So z1 is 0.81 and z2 is 1.73. So substitute the values here. So then we will get P of 0.81 less than or equal to z less than or equal to 1.73. So if you take these values in the normal curve, okay, so the normal curve is bell-shaped and it is symmetric about z equal to 0 and x equal to mu. This total area is 1 and this is 0.5. We know that this is 0.5. So according to normal curve, so here we have z1 and z2 values. Here we have both are positive values. That's why we need to take in the right side. If we have any negative value, we have to take in the left side. But here we are having only positive values. So that's why we need to take in the right side. So first value is, this is z1 and z2. So z1 value, z1 is nothing but here 0.81. So that is in the left side and z2 value is, let us assume that here that is 1.73. We need in between area. So that means we need in between area. So how to find in between area? So we have to take here to here area minus here to here area. Then we will get this area. Okay. So here to here area means that is a probability of 0 to 1.73. So 0 to 1.73 minus we need to take 0 to 0.81. So then we will get this area. So here to here area minus here to here area. So then we will get this area, this in between area. So that means P of 0 less than or equal to, that will be z less than or equal to 1.73 minus probability of 0 less than or equal to z less than or equal to, that is 0.81 in between area. So we are taking in between area. Okay. So then we will get, after taking like this, we will get in between area. That means 0.81 to 1.73. Okay, 0.812, we will get 1.73. So we have to take these values from the normal distribution table. So I will show you how to take these values. So see here. Here we have normal distribution table, so or normal table. Okay, so in this we need to take 0.81. So this is our 0.8. Here we have 1. Okay, so here we have z values are like this. Okay, here we have 0.8 and here we have 1. So 0.81, that will be this value, right? So that is 0.2910, 0.2910. We will get, if you take 0.81 value, so this is 0.8 and here we have 1, then we will get 0.2910. So and like that, if we want to take 1.73, so this is 1.7, right? So here we have 1.7. So 1.7, in 1.7 we need to take 3. So in 1.7 we need to take 3. That will be 0.4582. That will be 0.4582. Okay. So like that we can take 1.73 is 0.4582 and 0.81 is 0.2910. We have to take from the normal distribution table or normal table. Distribution table or normal table. So we have to take these values from the normal distribution table. Okay, so after simplification we will get 0. That will be 0.1672. So next, consider next problem. So our second problem is this one, right? So for the second problem, consider second one, that is P of probability of 1 minus 1.43 less than or equal to x less than or equal to 6.19. So that is equal to P of x1 less than or equal to x less than or equal to x2. That is equal to, we have formulas. So to find the z values. Okay, so those are z1, z2. So that is equal to z1 equal to x1 minus mu by sigma and z2 equal to x2 minus mu by sigma. So here this is x1 less than or equal to x, which will be in the form of x less than or equal to x2. So x is nothing but here minus 1.43 and x2 is nothing but 6.19. So z1 equal to x1 minus mu by sigma. So x1 is minus 1.43 minus what is mu value, already we have taken from the equation, that is mu equal to 1 and sigma equal to 3. So substitute mu value and sigma value, that is minus 1.43 minus mu value is 1 and sigma value is 3. So after simplification we will get minus 0.81. So z1 equal to, here we are getting minus 0.81 negative value. So next z2 equal to x2 minus mu by sigma. So we know that x2 is 1.69 and mu is 1 and sigma is 3. So substitute all these values in the formula. After simplification we will get 1.73. That means z2 equal to 1.73 positive value. So we have to put these values in probability of z1 less than or equal to z less than or equal to z2. So after putting these values, we will get P of minus 0.81. That will be minus 0.81 less than or equal to z less than or equal to 1.83. So observe the normal curve carefully. So here this is our normal curve. So we know that a normal curve is symmetric about z equal to 0 and x equal to mu, and the total area is 1 and this left side area is 0.5 and right side area is 0.5. So if we have any negative values, we have to take in the left side. If we have any positive values, we have to take in the right side. But here we are having one negative value and positive value. So this is z1 and this is z2. So z1 we have to take in the left side. So because that is negative value. So that is minus 0.81. And coming to the z2 value. So z2 equal to, here we have 1.73. We need in between area. So we need this total area. That means here to here area plus here to here area. So that means minus 0.81 to 0 plus 0 to 1.73. So we need this total area, that is probability of minus 0.81 less than or equal to z less than or equal to 0. So that means here to here area plus. So this will be plus probability of 0 to 1.73. So 0 to 1.73. That means we can write like this. Probability of 0 less than or equal to z less than or equal to 1.73. So but so in the normal curve, that is symmetric, right? So symmetric about x equal to z equal to 0 and x equal to mu. So that's why, so in the normal curve, one possibility is there. So that is minus infinity to 0 equal to 0 to infinity. So according to that one, so we can write minus infinity to, so here we have minus infinity to, sorry, minus 0.81 to 0 can be written as 0 to 0.81. So that's why I am writing here, we have minus 0.81 to 0 is there. So here I am writing this one to probability of 0 to 0.81. So I am converting this negative value into positive because there are no negative values in the normal distribution table. So that's why I am converting into positive. So probability of 0 to 0.81 plus 0 to 1.73. So we have to take these values from the normal distribution table or normal table. Okay. So normal table. So after taking the 0.81, we will get from the normal distribution table, that is 0.2910, and this will be plus. So plus 1.73. So here we have 1.7 and here we have 3. Okay. So take this value. So that is 0.4582. Okay. So after simplification, we will get 0.7492. So coming to the next problem. If x is a normal variate with mean 30 and standard deviation 5. So probability of P of 26 less than or equal to x less than or equal to 40. So second question is P of x greater than or equal to 45. So this will be in the form of x1 less than or equal to x less than or equal to x2, and this will be in the form of x greater than or equal to x1. Okay, so first of all, I am considering this one. But before that, so what is in the normal variate with mean? Mean is nothing but mu, and standard deviation is denoted with sigma. So here we have mu equal to 30 and standard deviation sigma equal to 5. So coming to the first question, so that will be P of 26 less than or equal to x less than or equal to 40. So this will be in the form of probability of x1 less than or equal to x less than or equal to x2. So here x1 equal to 26 and x2 equal to 40. So according to normal distribution formula, the formula is z equal to x minus mu by sigma. So here we have x1, x2, both two values are there. So that's why we need to find z1 and z2. So z1 equal to x1 minus mu by sigma and z2 equal to x2 minus mu by sigma. So now substitute the values here. So here x1 minus mu by sigma. So x1 means here x1 is 26 minus mu value is 30 and sigma value is 5. So substitute all these values in the formula, and after simplification, we will get z1 equal to 0.8 positive value. So next, coming to the next question. So next formula, so that is z equal to x2 minus mu by sigma. Here x2 value is 40 minus mu is 30 and sigma is 5. So 40 minus 30 by 5. So after simplification, we will get that is equal to 2. So that means z2 equal to 2, z1 equal to 0.8 and z2 equal to 2. So now probability of z1 less than or equal to z less than or equal to z2. So that is equal to, this is z1 value and this is z2 value. So probability of 0.8, z1 value is 0.8 less than or equal to z less than or equal to z2 value is 8. So according to our this is a negative value. Okay. So here we have z1 equal to minus 0.8. So here we have z1 equal to minus 0.8. So we have to take in the left side. Okay. So that is z equal to 0. So here we have negative value. Z1 value is negative value. So that's why that is minus 0.8. We have to take in the left side. If we have any negative value, we have to take in the left side. If we have any positive value, we have to take in the right side of the curve. Okay, so but here z2 value is positive value. That's why we are going to take in the right side. So that is z2 equal to 2. So we need this total area. We need this total area. That means here to here area plus here to here area. That means minus 0.8 to 0 plus 0 to 2. Okay, so that is minus 0.8 to 0 plus 0 to 2. So minus 0.820, 0 to 2. So we have to convert it. According to normal curve, the normal curve is symmetric about z equal to 0. That means minus infinity to 0 can be written as 0 to infinity. So here I am having minus 0.820. So we are converting to positive value. That means 0 to 0.8. So that's why minus infinity to minus 0.820 can be written as 0 to 0.8. Okay. So here we have 0.8 and here we have 2. So from the normal distribution table, our normal table, we have to take 0.8. In 0.8, we have to take 0. In 0.8, we have to take 0. This value is 0.2881. Okay. So in 2, so like this we have. So like this we have. Okay. So like this, these are z values. Okay. So like this we have values. So here we have 2. That means 2.0. In 2.0, we have to take 0. In 2.0, we have to take 0. That value is, this value is 0.4772. So we have to take these values from the normal table or normal distribution table. So this is plus. Okay. So after simplification, we will get that is 0.7653. So next one, consider. So next question is probability of x less than or equal to, x greater than or equal to 45. So probability of x greater than or equal to 45. That means this will be in the form of x greater than or equal to x1. So we have a formula that is z1 equal to x1 minus mu by sigma. So here x1 value is 45 and we know that mu is 30 divided by sigma is 5. So after simplification we will get 3. So that means which will be in the form of p of x greater than or equal to x1. So we have to convert into z's. So that will be probability of z greater than or equal to z1. So z greater than or equal to z1 value is 3. So that's why this is positive value, right? So we know that the normal curve is symmetric about z equal to 0 and x equal to mu, and this total area is 1 and this is 0.5 and this is 0.5. Okay, so and here we have positive value. So we have to take positive value in the right side of the curve. So that's why that will be z1 equal to, that is 3. We have to take in the right side. So here we have a greater than or equal to symbol. So that's why we have to take the right side area. So we have to take the right side area. So if we have p of z less than or equal to 3. So if we have like this, we have to take, this is a positive value. So that's why we have to take in the right side, that is z1 equal to 3. And if we have less than or equal to symbol, we have to take left side area from the point. So from the point we have to take the total left side area. But here we are having p of z greater than or equal to 3. Greater than or equal to symbol is there. So that's why from the point we need to take only right side area. So we need only this area. So how to find this area? So we know that this total area is, right side area is 0.5. So if you take 0.5 minus here to here area, 0.5 minus here to here area, then we will get only this area. So that's why 0.5 minus 0.5 minus 0 to 3. So this is nothing but 0 to 3. So 0.5 minus 0 to 3. So after simplification, so before that we need to take 3 point. So this is let us consider this is normal curve. So if this is normal curve, so here we have some 3 and these are the, so that means 3.0. In that we need to take 0. So if you take this value from the normal distribution table, we will get here that value is 0.4987. Okay, so we have to take this value from the normal distribution table. I already have shown. Okay, so how to take that value? So 0.5 minus 0.4987. So after simplification, we will get 0.0013. That will be. So coming to the next question. The next question is, see here, the mean and standard deviation of normal variate is 8 and 4. Find first one, p of 10 less than or equal to x less than or equal to 15. And second one is p of x less than or equal to 15. So mean. So here mean is nothing but here 8 and standard deviation is 4. Mean is denoted with mu and standard deviation is denoted with sigma. So mu equal to 8 and sigma equal to 4. So coming to the first question. So what is our first question? P of 10 less than or equal to x less than or equal to 15. So now which will be in the form of probability of x1 less than or equal to x less than or equal to x2. So here x1 equal to 10 and x2 equal to 15. So coming to the formula, in the normal distribution we have formula that is z equal to x minus mu by sigma. But here we are having x1 and x2. So that's why we need to find z1 and z2. We have z1 equal to x1 minus mu by sigma and z2 equal to x2 minus mu by sigma. So the x1 value is 10 minus mu is 8 and divided by sigma value is 4. So after simplification we will get that is 0.5. So positive value. So like that z2 equal to x2 minus mu by sigma. So what is x2 value? Here we have x2 value is 15. So 15 minus mu value is 8 divided by sigma value is 4. Okay. So 15 minus 8 by 4, then we will get 1.75. So Z2 value is here 1.75. So both are positive values only. So 0.5 and 1.75. So coming to the probability of Z1 less than or equal to Z less than or equal to Z2. So here Z1 value is 0.5 and Z2 value is 1.75. So both are positive values. That means we have to take these values in the right side area. So here in the normal curve, this is z equal to 0 and the positive first value is z1 value is here 0.5. So and z2 value is this is 1.75. So let us assume, so that will be here. So we need only this in between area. Okay, so how to find this area? Already we have discussed in the first problem. So here to here area minus here to here area. So that means 0 to 1.75 minus 0 to 0.5. So if you take like this, okay, so here to here area minus here to here area, then we will get this middle area. Okay, so that means 0 to 1.75 minus 0 to 0.5. So then we will get only this area. That means probability of 0.5 to 1.75. We need only this area. So then we will get this area. Okay. So we have to take these values from the normal distribution table. So in 1.7 we need to take 5. So then we will get, so we in the normal distribution we have to take like this. Okay. So in 1.5 we need to take 5. Then we will get 0.4599. Okay. So in 0.5 we need to take 0. So then we will get 0.1916. Okay. So after simplification we will get 0.2683. Okay, so coming to the next problem. So this is next one, second question. P of x less than or equal to 15. So P of x less than or equal to 15. So that is equal to P of x less than or equal to x1. So z1 equal to, so this is x1. Okay, so z1 equal to x1 minus mu by sigma. So here x1 equal to 15 minus mu value is 8 divided by sigma value is 4. So that is equal to 1.75. So P of z less than or equal to z1, that is equal to P of z less than or equal to z1 is 1.75. So observe carefully here. In the normal curve, so that is normal curve is symmetric about z equal to 0 and x equal to mu. So this total area is 1 and this is 0.5 and this is 0.5. So here we are having positive value. So that's why we need to take in the right side. So that's why that is z1 equal to 1.75. So let us assume that that point is here. Okay. So but here we are having less than or equal to symbol. So if we have less than or equal to means from the point we need to take only left side area. So we need left side area. Okay. So that means this total area is nothing but we know that is 0.5. So 0.5 plus here to here area. That means 0 to 1.75, right? So this total area is 0.5 up to here area. So up to here area is nothing but 0.5, and we need this area also. So that means 0 to that value is 1.75. So 0 to 1.75. So 0.5 plus P of 0 to probability of 0 to 1.75. Okay, so if we take this value from the normal distribution table, so if we take this value from the normal distribution table, so how to take this value in normal distribution table? We have to take 1.7. We need to take 5. So 1, 2, 3, 4, 5 like that. That value is there. So in 1.7 we need to take 5. So we will get this value. That value is 0.4599. Okay, so 0.5 plus 0.4599. So after simplification, we will get, after adding these values, these two values, we will get 0.9599. So now coming to the next question. The mean and the standard deviation of the class obtained by 1,000 students in an examination are respectively, so 34.5 and 16.5. Assuming the normality of the distribution, find the approximate number of students expected to obtain marks between 30 and 60. So here we need to find P of 30 less than X less than or equal to 60, or we can write like this also. So because the normal distribution is continuous, so in continuous we can take less than or equal to also, no problem. Okay, so coming to the our question, so mean is nothing but here 34.5. So we know that mean is denoted with mu. So mu is 34.5 and standard deviation is here 16.5. So sigma is denoted with this one, standard deviation is denoted with sigma. So that's why sigma equal to here, that is 16.5. So now we need to find the marks between 30 and 60. That means here we need to find P of 30 less than or equal to X less than or equal to 60. Or we can write like this also. So 30 less than X less than 60. So because normal distribution is continuous probability distribution. So that's why we can write P of 30 less than or equal to X less than or equal to 60. So that is equal to, that is X1 less than or equal to X less than or equal to X2. That means this is X1 value and this is X2 value. Here X1 is 30 and X2 is 60. So coming to the our formula, Z1 equal to X1 minus mu by sigma. So X1 is 30 minus mu is 34.5 divided by sigma is 16.5. So after simplification we will get, that is 0 minus 0 point negative value we have to take in the left side in the normal curve. Okay, so that is minus 0.27. Z1 value is minus 0.27. So coming to the Z2 value, Z2 equal to X2 minus mu by sigma. So here X2 is 60 minus mu is 34.5 divided by sigma is 16.5. So after simplification we will get, that is 1.5. Okay, so now probability of Z1 less than or equal to Z less than or equal to Z2, that is equal to, so Z1 value is here minus 0.27. So this is Z1 and Z2 value is here 1.5. Okay, so coming to the normal curve. Okay, so this is our normal curve. So in the normal curve, Z equal to 0, and if we have any negative value, we have to take in the right side. If we have any positive value, we have to take in the right side. Okay, so here we are having negative value. So that is Z1 equal to, let us assume that value is here. Okay, so that is 0 minus 0.27. So we have to take in the left side, and Z2 value is positive value. That's why Z2 equal to 1.5. So we need in between area. Okay, so that means here to here area plus here to here area. That means that is minus 0.27 to 0 plus 0 to. So here to here area means that is 0 to 1.5. 0 to 1.5. Okay. So minus 0.27 to 0 plus 0 to 1.5. Okay. So but in the normal curve, that is symmetric about Z equal to 0. So that means in the normal curve, that is minus infinity to 0 equal to 0 to infinity, because that is symmetric about symmetric about z equal to 0 and x equal to mu also. So that's why we can write minus infinity to 0 can be written as 0 to infinity. So like that, here we have minus 0.27. So minus 0.27, integration over minus 0.27 to 0, we have to convert into 0 to 0.27. Okay, because that is symmetric. Normal curve is symmetric. That's why we can write like that. Okay, so that means, so minus 0.27 to 0 can be written as 0 to 0.27. So okay, we have to convert into positive. Okay, so because in the normal distribution table we have only positive values, that's why we need to convert into positive. So probability of 0 less than or equal to z less than or equal to 0.27 plus probability of 0 less than or equal to z less than or equal to 1.5. That means 0 to 0.27 plus 0 to 1.5. So we have to take these two values from the normal distribution table. So if you take minus 0.27, 0.27. So here we have 0.2, here we have some 7. Okay, so we have to take this value, that is 0.1064. Okay, so in 1.5, so here we have 1.5, in 1.5 we need to take 0, so that value is 0.4332. So we have to take these values from the normal table or normal distribution table. So after simplification we will get, that is 0.5396. Okay, but in the question they have mentioned that, so find the approximate number of students expected to obtain the marks between 30 and 60. But here we have how many students are there? 1000 students are there. So that's why we need to multiply with 1000. Okay, so therefore the number of students obtained between 30 and 60 is, so that is 1000 into this value. 1000 into this value. That means 1000 into 0.5396. After simplification we will get 539.6. That is approximately 540. Okay, so 540 students are obtained between 30 and 60. Obtain the marks between 30 and 60. So this is the required solution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.